I want to close out the video for the week with just a few miscellaneous electricity items, circuit items, especially as they pertain to just practical everyday things like the power in your house or the power in an electric drill that you might use to fix something in your house. So I'll start with power distribution systems. And power distribution system is just a fancy way of saying, how is it that electricity is organized within your home or a building like this building here that I'm in right now, in order for us to get all of our electricity needs, right? And there is a picture here on this slide, the power distribution system slide, that I would like you to take a look at and just kind of pause for a few moments and kind of notice what you notice, right? What do you see there? I'll just pause awkwardly. Okay, one thing that you should notice is that all of your outlets in your home or in a building like this are in parallel. Why is that? Why would that be so important that your outlets are in parallel? Okay, well, here's something interesting about a parallel circuit. So if here is a resistor, here is a resistor, here is a resistor, right? If I take any one of these out, I still have a complete circuit, right? Let's say I take out this resistor, right? And now it looks like this. So in other words, I've unplugged my television, right? Well, you know what? Current still goes here, and current still goes here, right? I still have a complete circuit. The current can flow one full loop here, and the current can flow in one full loop back over here, okay? But let's suppose that I have a series circuit. Still 3 resistors now in series, okay? Let's suppose I take one out now. I unplug my television. I've broken the circuit, right? The current is not going to leap over my old resistor so that it can go back and complete the circuit, right? I've broken my circuit. So the power in your home can never be series because the second you unplug your toaster, all the power in your house would go out. That would suck. Okay, so that's one thing you notice. What's another thing you notice? Well, you notice there are these fuses, okay? What is that all about? What is the function of a fuse? You hear about fuses, burning out, and you needed to flip a breaker, all this. So what's actually going on there? Okay, and so I'm going to skip ahead 2 slides to fuses just so we can focus on this question. Fuses are the solution to the problem of what if there are fluctuations of current coming from a power plant. Okay. There are many reasons there could be a fluctuation of current coming from a power plant. It's very rare, but it does happen. And if you have a sudden sharp fluctuation, like in the case of, let's say, a lightning storm, you have a sudden sharp fluctuation in current, and that current becomes orders of magnitude higher than your appliances can handle, then suddenly you ruin almost every appliance in your house, right? Imagine suddenly there's a thunderstorm and you have to replace your refrigerator, your dishwasher, your toaster, your hair dryer, etc. That would be inconvenient, very expensive, and so what a fuse does is it is set so that there's a maximum amount of current that can go through it before it burns out. Okay, it's designed to actually burn out if the current that it can handle is exceeded. Okay, and that is set around at the safety level of the appliances in your house, right? So that if there is that surge of current, the fuse burns out before that current actually gets to the appliance and ruins the appliance. Pretty cool, right? Pretty clever way of making it so that we can protect the stuff that we pay a lot of money for. All right. Next, I want to talk about this. Sometimes you see 2 prongs, and sometimes you see 3 prongs inside of a plug. What's that all about, right? Well, the 2 prongs are obviously important because, if here's your plug, right? Inside a wire, so let's do a hairdryer again. Oh my gosh, that's just the worst. So it's blowing out all this air over here, right? And it's plugged into the wall. So we'll just say that this here is the wall and it's plugged into the wall, right? Well, what's actually happening here is you have a complete circuit. You have a parallel circuit where like the current's flowing in through here, right? Going through whatever motor happens, right? And then it's going back through, there's actually 2 wires inside of every cord, one that goes back through the other prong. Okay? And so now you have a fully parallel circuit. It's like 2 lines. So this technically is this, right? Remember I said that there's many different ways you can draw a picture and make it more simple? Well, all this is 2 prongs, right? And then a resistor on the other side. Okay? And then that's then in parallel with the other outlets in your entire house. But this is really just this. Super simple, right? And so why the third prong? Well, what happens if this malfunctions and then suddenly there's like some current that spills out, right? And then you're holding your hairdryer and you get just massively electrocuted because the thing malfunctions, okay? That also would suck, right? And the goal of drying your hair and making your hair look nice would be totally ruined because your hair would be huge because you're electrocuted, right? So what that third prong does is it collects, right? So it allows any of that spilled out leakage of current then to go back through and go what's called the ground, right? And the ground means that this is basically a direct current path, not back into your house, but down literally into the ground, into the floors, right? And therefore, it dissipates that current into the ground instead of into your body where it's uncomfortable and inconvenient, okay? So if anyone asks you why the 3 prongs, now you know, okay? And I think that's it. This is a solid, and I know probably fairly exhausting crash course in circuits. And, you know, I with this chapter especially, I want you to consider what we've done in lecture to be kind of just the bare bones, right? This is the foundation. Something like circuits is a lot like a new math procedure, like foiling, right? Or solving quadratic equations, or solving systems of equations, right? It's the sort of thing where to get the hang of it, you need to do it over and over and over again, okay? As I said before, there's many examples in the book that aren't in the homework. There's many examples just online if you want to solve just Google Kirchhoff's laws circuits problems or solving for current. And if you want any more resources from me, you can ask me. But practice this. Practice solving circuits so that it feels comfortable and less scary, because I know that some of the systems of equations math in this chapter can be a little bit scary. On a positive note, I want to end and say this is the hardest mathematically it's going to get in physics this semester. If you can handle this, you can handle anything else that I throw at you, and that's pretty cool. After this chapter in circuits, we move on next week to one of my favorite topics in physics, which is magnetism. Magnetism is one of the areas where magic really shows up in the world, right? Because it's an invisible force that you can see and feel, and that's pretty neat. And I don't think it's a coincidence that magnets and magic both start the same way. M-A-G. Someone look that up. All right, have a nice week. Bye.